Okay, so we're going to continue today. You got two handouts. You got exercise 211, which is what we're going to do in class today, and you also got assignment 202. Assignment 202 isn't due for a while. It's the physical model is actually due on October 14th, so it's a ways off. But the digital file, I make everybody turn that in on October 5th. So you're going to actually make a physical model. You're going to laser cut it. And we'll talk about prepping a laser cut file, but you will go schedule your own time with one of the lab techs to cut your file. It's a relatively simple process. I will do an example cut. I'll bring the cut over and I'll show you how it all glues together. I should have brought it over right now, but I'll go get it after I finish talking today, and a sample of what I'm talking about in terms of this topography. What we want to start working with, and thus far we've gotten a little bit in this direction because we did the organic shapes, the cushions, the pillows, that sort of thing. But what we want to do is we want to start really being able to work with complex surfaces rather than just kind of standard shape objects. We're getting away from the rectangles and the cylinders and that sort of thing into more complex shape. And really the best way of dealing with that is to start working with terrain or topography, because that type of file contains lots of ups and downs, lots of complex curvature, and as you learn to manipulate that, you start to have a much better understanding of how to work with complex surfaces. So I use it, and we spend a lot of time on topography, but it's not limited to topography. It's really showing you a variety of ways of working and manipulating these materials. So today we're actually going to get our topography information from SketchUp. I used to do an exercise where I gave everybody a flat set of topo curves, and then we moved them up in space and we created the surface out of those curves, which is certainly one way of doing it. Generally, for the approximations that we're doing, working with a SketchUp file is a pretty easy, free way of getting terrain information. It's not perfectly accurate, but it's reasonable. If we had a specific site where we had a topographic survey done, we would go from that data rather than from this kind of generic form. But I think working from the generic form for most of what you're doing in studio life and in your studio classes is very reasonable. So what I'm going to do is I'm going to go ahead and I'm going to open SketchUp. I know. Can you believe it? I'm opening SketchUp in this class, right? And we, of course, are still way behind, and we have SketchUp 2013. Who knows why? Oh, it's going to make me select a template. Doesn't really matter too much. And so we're going to go ahead and, no, I know there's an update. It's been a while. And so what we need to do is we need to get information that's location information. So at the top of SketchUp, and really there's very little that you have to do in SketchUp in this class, so it's pretty easy to follow along. Basically, we're going to click this little map-looking icon, and that will bring up the Add Location dialog box, right? Yes. I love it. So here's a perfect example of where everything that I had planned for today is going to fail miserably. Okay. Let's see here. Right. Okay. How do we want to deal with this? All right. So I tell you what. What we're going to do for right now is you're all going to get some time to work on your chairs and your tables. And I'm going to figure out how I'm going to solve this, because it doesn't do me any good to, if I can't get this information, I can't teach you anything. So let me think about this, and maybe I'll have you download a SketchUp file. I'll create it on my laptop or something. But yeah, so anyway, to be continued. Start working on your chairs. Let me work on this for a little bit. Okay, so I can't fix not having the current version of SketchUp today, because I obviously have to get administrator rights and have all the machines updated, whatever. So what I did was I uploaded a sample file. Everybody will have the same terrain today instead of different terrain. So we're going to modify on the fly kind of how this works, which I said in the handout for exercise 211 that you were going to need to do comments today as your first set of comments. You'll be exempt from doing the comments because now everybody's doing the same one, so it kind of defeats the purpose. So anyway, if you navigate to exercise 211, which would be under Exercises, Digital Tools 2, Fall 2015, and then click on Exercise 211, you will see under the second bullet point of Part 1, here's a sample SketchUp file to work with. This was a Hawaii example, which works nicely because it has pretty good values to work with and whatever. So you'll want to right-click on this Hawaii example terrain and save link as, and save it to your flash drive. It'll turn up as a SketchUp model file, a .skp. And I'll go back through next class, hopefully after we get SketchUp updated for everybody. I'll walk you through the SketchUp part of this so you don't feel like you got lost in that. But I want to make sure that we still have a productive day-to-day and don't waste our time. So I have that SketchUp file already saved on my flash drive. I have a new Rhino document that's opened in large object inches as my template. And I'm going to go ahead and bring in that SketchUp file. And once again, I'm following along with the tutorial 5.23, Getting Topography from Google SketchUp. And so that's kind of where I am here. Okay, so we already have that. And so what I'm going to do is I'm going to go ahead and bring in the Rhino terrain. So I'm going to go to File and then Import. And I'm going to look for my flash drive in that SketchUp file. So let's go into Dropbox here, 211. There's the file. If you're not seeing it, it's probably because you don't have all compatible file types checked. So you might need to adjust that so that it's all compatible file types. And then you should be able to see the Hawaii example terrain that I just downloaded. When I click on Open, it's going to bring in my SketchUp file. And SketchUp works very differently from Rhino. SketchUp comes in as what's called a mesh file. And basically how SketchUp deals with complex surfaces is it makes triangles out of it. And you've probably seen this when you've worked in SketchUp before, that if anything's too complicated, it just divides it up into smaller and smaller triangles. Well, when we bring in this terrain, Rhino converts that into what's called a mesh, which basically means that I have points, in between them are little triangles, and I get my terrain. So we get some options here. We're going to bring it in as a mesh, right? And it's going to join the edges and the faces together. And so I'll go ahead and say OK. And I'll get the whole file coming in. Looks like the little person showed up here as well. We can go ahead and get rid of the little person. We don't need the person. And then let's go ahead and zoom out of the perspective view here. And we can see that that terrain exists. Let me switch into shaded mode so that we can see it a little bit better. It also comes in with a flat plane. In SketchUp, I can't show you this live, but SketchUp has two versions of the file. One is flat, and one has the terrain in it. When you save it, we get a second surface here. I'll go ahead and get rid of that. And let's have a little bit closer look at the SketchUp file that is the terrain. So if I look at this, we can see that it's made up of a bunch of little itty-bitty triangles, right? And so if we look carefully in this valley, for example, we get kind of a jagged step pattern because of the of the nature of the triangles. Okay? Same thing on each of these ridges, right? In reality, the ridge doesn't have these little divots in it, right? It's a smooth ridge. So we need to transform this into a shape that we can really work with and work with well. So we're going to use a command that's called the contour command. And it's Rhino tutorial 5.20 if you want to follow that one. But I'm going to go ahead and do it for you as well. And what we're going to do is we're going to cut contours in two directions. One is going to be in the X direction, one is going to be in the Y direction. And we're going to divide this surface up into a bunch of perpendicular lines. And then we're going to work from those lines. So contour, the easiest way to understand it is when it's in the Z direction. It's just like topo lines, where we have little stripes that it cuts through a surface that are an even interval apart. We're going to do it in the X and the Y direction, so it'll look slightly different. So what I'm going to do is I'm going to go up to Curve, and then I'm going to select Contour. It's Curve from Objects, Contour. You can also just type Contour. And it's going to say up here, Select Objects for Contours. So the object that I want is this surface, right? And actually, before I actually get too far into this, I'm going to change my layer so that it's on layer 1 instead, so that these contours are created on a specific layer. So I have my object selected. I'll go ahead and press Enter when I'm done. Contour base plane, or plane base point. This is basically the corner at which you want to start. So because this is a mesh, all of my normal object snaps don't work. So I actually have to come down here, and I'm going to choose knot and vertex to be on, which will then allow me to snap to the mesh instead of to the surface because it's a mesh. Right? Then I'm going to turn on ortho and make sure I just go out. This is direction perpendicular to the contour planes. I'm going to go out in the x direction here. And I want to make sure that I'm way longer than wherever the surface is, because if I snap to the surface by accident, my contours aren't going to be the way that I want them to be. They're going to be kind of on a diagonal instead of flat. So I just want to make sure that I'm way off here in space. And when I click, it's going to say distance between the contours. And this is going to be a little bit of a guess because I don't know how big this piece of terrain is that I captured. If we knew how big it was, we could guess on what interval. So 1 foot, 5 foot, 10 feet, 100 feet, I don't really know. So I'm going to start at 50 feet, and we'll see if it's too far apart or too close together. So I type 50 in the little foot sign, and it goes across my surface and creates a series of parallel lines that go up and over the surface. So if I were to turn off the Google Terrain, we'd see that I basically have a bunch of lines that now represent one direction of the terrain. Does that make sense so far? Okay. What I'm going to do now is I'll turn this back on, and I'm going to perform the contour but in the opposite direction. So I'll go back to surface, curve from objects, contour, or type contour. Select objects for contours. I have to pick the surface again, the mesh. Right? One of the things that people will do, one of the steps that will trip you up, is if you don't go back and select the mesh anymore and you do a contour of the lines you just created, you'll end up with a bunch of dots. I'll show you an example of what that does in a second. Right? So I'm going to select the object, which is there, the surface. I'll go ahead and hit enter. Select the base point. We'll select right down here, same base point. And this time I'm going to go way off in the y direction. So I'll go up here. I'll go ahead and click. Now it says distance between the contours. It remembers my last value of 50 feet, so I don't have to put that in again. And I'll go ahead and hit enter. And I'll get another set. So let me go ahead and turn off the surface. And so now, right, I have what looks like a wireframe that represents the surface itself. Okay? What it is it's a series of individual curves that go across the surface and cross each other. Okay? So if I jump back into my top view, one of the ways I can confirm that this is correct is I can look and make sure that this is in fact an orthogonal grid. If I look in the top view and it's not a bunch of squares, we have a problem. Okay? So the next piece of this puzzle is that what I'm ultimately going to do is a curved network of all these curves. So it's a complicated curved network. Before we did just curves around the perimeter and maybe one curve or a second curve in the cushion, remember? This time it's a lot more complex than that. So I do, however, need to make sure that my edges are all nicely neat. So I'll go ahead and take a line that's a few pieces in on the edge, and I'm going to type trim, or select edit trim, and I'm going to select all of the lines up to that point. And so it gives me a nice sharp edge, not a ragged edge. Okay, I'll hit enter to finish, and we'll have to clean up and get rid of a few more lines here. Those can go away. I'll do the same thing down here at the bottom. I'll go ahead and type trim. I'll drag through all of those points. Those goes away. Get rid of these couple extra lines. Do it once more here. Remember, if I'm selecting from the right and to the left, it's selecting everything that it touches. Get rid of a few of these. Now I have to do the top still. So I'll type trim one more time. And we'll get rid of those. And so what happens is now I have basically a perfect square, right, or a perfect rectangle. I have a perfect grid, and now I can actually build a surface out of this curved network, or out of this network of curves, right? So here comes the part where I do the curved network, which you've already done once in the class, but this is reiterating it. Okay? I'm going to go ahead and select all of the curves like that. I'm going to put this on a new layer, so I'm going to move down to layer 2 when I do the curved network. And I'm going to come up to surface, network surface, or excuse me, surface curved network. right? And it's going to say, you have more than 100 lines. Are you sure you want to do this and not crash the computer? You're going to say, yes, I have faith in the computer to do this, okay? Which might be a mistake. This process can take somewhere in the neighborhood of 10 minutes. It could also happen really fast. Just depends, okay? So when it comes up here, I have some tolerances. I have edge curves and interior curves. I like to drop 1 decimal place on the edge curves so that it's not quite as precise, but it saves a little bit of processing power. We could also change these to be loose if it crashes in the process. Since it isn't, I'm going to leave it at position. So now I'll go ahead and say OK, and we'll let it do its work. This process can also take a while, so we'll be patient. On the older machines, when we used to be in the other lab, this process could take like 20 minutes. So the good news is it doesn't anymore. OK, so it finished. And once I do this, it's going to start moving very, very slow on the computer. So I have to be patient. Like if I try to zoom in, it's going to lag quite a bit. And that's because the density of this surface that I just created is really, really intense. Okay? So I'm going to go ahead and turn off my layer 1 here. And again, huge lag. Be patient. Right? And you see that this shape is now virtually a solid object, right? Because the lines and stuff are so dense together. If I select it by clicking on it, it will turn entirely yellow, as opposed to just seeing the edges. Okay? So what I need to do is I need to rebuild the surface. And I'm going to rebuild to an approximation of the surface. And then I'll show you some examples of how it changes. So I'm going to type rebuild. And this will bring up the rebuild dialog box, the rebuild surface here. I'm going to change my U and my V, and we'll start at maybe 500 by 500. Come on. And I'll go ahead and say OK. And after that's done, my computer should get a lot faster. Okay? And so I've changed the density of the mesh on the surface, basically. Okay? And so here we are with a relatively exact copy of the surface that I had. It's a little smoother. It's not quite as triangulated as the original surface, but I can still see how I can still see all of the individual little triangles? Do you see that? The remnants of those triangles? Okay. If I take this, and I'm going to copy a few instances so you can see how this changes. So let me go ahead and copy this in place, and I'm going to change the layer. Okay. So now I have 2 that are right on top of each other, okay, that are identical. I'm going to take the one that's on top, this blue one, and I'm going to rebuild it again. And this time, instead of 500 by 500, I'm going to do 100 by 100. Oops, if I can type. And I'll go ahead and say OK. Okay, so now I can start to compare. Okay, so my first surface was the purple one. Okay, and you see how we can still see the little leftover remnants of the triangles? When I rebuilt to 100 by 100, there's a little bit of the triangle left, right, in the valleys, but it's starting to smooth out a lot more than it was. You guys see the difference? Okay, so let's say that instead of doing it at 100 by 100, I copied it, and you don't have to copy it. I'm showing this so we can go back and forth between them all. And let me change to this layer. Okay, and this time I'm going to rebuild the green surface to maybe 50 by 50. That's OK. Okay? And when you see them overlaid, you can really start to see how they've approximated, right, versus the other. So let me go ahead and turn that off. And now when we look at it, right, there's almost none of those artifact triangles left. It's gotten much, much smoother, right? So the more I rebuild it, the less of those triangle artifacts that I get, and the smoother the surface is, right? And so you, as you're working on your project, have to decide what level of smoothing versus accuracy do you want, right? Because as I increase the smoothing, let me turn back on the original one, right? I decrease some of the accuracy. So some of the ins and outs that were represented by the triangle, I start to lose as I rebuild. If I rebuild too far, right, let me go ahead and turn off. Let me copy this in place. And we'll put it on this layer. And I rebuild this. Let's say I rebuild it and it's 10 by 10. Right? You see how I keep going down. Okay? Now it starts to be significantly smoother, and I start to lose more and more of the original shape. So let's turn this off. There it is, very, very smooth. Right? No triangles left at all. But if I compare it to what the original was, there's a lot of data that's not there anymore. Right? So this ridge is much shorter. Actually, each of these ridges is much shorter. Right? The valleys are not quite as sharp. So there's a distinct difference in all of them. So if I were to pull them out so that I'd see each one, let me do them in order here. All right, so a bunch of the same terrain examples here, right? If I were to render those out, go to my environment, let's turn this to white, and let me load just a basic gray material. All right, so if we look at this, render it out. Oops. Missed applying it to this one because it was locked. Let me do one more thing here. Bigger so you can see it a little bit better. Right, you can see artifacts of the original triangles in this, and it gets increasingly smoother as we go along with each version. Okay, I probably need a little bit more lighting. I'll do a better rendering so you can see the difference in each of these. The point is, the more you rebuild the surface, the finer and finer, the less and less of the detail that goes away. So we can see here we've got little sub-ridges going into this valley. The sub-ridges are still here. The sub-ridges are still here. But when we get to the 10 by 10, we lose those ridges altogether. Right? So it's just a matter of approximation, and you have to decide which one is the right level of approximation for what you're working with. Okay? So let me just double check where we are here. I want to make sure I cover everything I wanted to cover today. Okay, so one last thing that I'm going to do. I'm going to work with this green one as an approximation. And what I want to do is I want to generate a flat topo map of what the topography is. So I'm going to use the contour command one more time. This time, the contour command will be in the z direction instead of in the x and the y. So I'll do it one last time. And so this time, let me create a new layer for this. And I'll call this topo lines, if I can type, which I can't. And I'll make that active. I'm going to work with this surface again. So I'm going to use contour. So once again, it's edit, or excuse me, curve from objects, contour, or I can type contour. My object is going to be this object. Go ahead and hit enter. My contour base point is exactly in the same place. But this time, instead of in the x or in the y, I want it to be in the z. So I'm going to switch my view so I can go straight up in the z. I have to make sure that I am going straight up, which I am. And now I can specify an interval, right? And so this works just like topography. Maybe it's at 10 feet, maybe it's at 40 feet. Depends on how far or how dense you want the contours to be. So let's say that we want it to be at, oh, I don't know, 10 feet. I'll say 10 feet. And when I hit enter, we'll see it build up and generate those contours at every 10 feet. Right, obviously, this is a really big site. 10 feet was probably too small. Right? I probably should have done 50 feet. No, small objects inches. Or large object inches, sorry. I always stick with large object inches. Okay, so it just finished. Right, and if I were to zoom in and look at it, you'd see that there's a bunch of, let me turn off the surfaces so that we don't get distracted by them. Right? I now have a bunch of topo lines, so to speak, that represent this piece of land. Okay? If I were to look at it in one of the front views, right, we'd see perfectly horizontal lines as a way of confirming that they are correct. Okay? So there they all are. If I wanted to make them, say, into an AutoCAD file to export, because I wanted these topo lines to go on a drawing somewhere, right, I'm going to use the project command. Again, all these are tools that we've used before. I'm just showing you a different way of doing it. Right? I'm going to work in the top view. I need a surface to project onto. And let me go ahead and create a new layer for this. We'll call this AutoCAD. All right, so let me go ahead and create a surface. Just a rectangular surface larger than my curves. I'll use project. So again, in the top view, I can go and type project or curve from objects, project. Select curves and points to project. It's going to be those. All right, I'll hit enter. Select object to project onto. There's the surface. I'll go ahead and hit enter. And it will drop all of those down onto my surface. And again, I should have fewer density because it wouldn't be spending quite this long to do it.
Make 2D faster?
Maybe, except that we can't be confident in our scale at that point. You'd need an object that you can reference for scale. So it's a similar concept. We won't get to make 2D until later on. You're jumping ahead. Make 2D is far better for like sectional drawings and elevations and stuff. Okay, so here it is in its flat form. Right, there it is flat. I'm going to go ahead and move this over here. Okay, and with it selected, doesn't matter what view, I can go to File, Export Selected, and I can specify that I want this to become an AutoCAD file. Right? Notice that I also have the ability to make it an Illustrator file. I have quite a lot of output options. Okay? We're going to go with AutoCAD for this one because we're practicing AutoCAD. We're going to take it over and laser cut it, that sort of thing. We're going to deal with colors and all that sort of thing as we go forward. So I'll go ahead and click on Save. Oh, I have to give it a name first. And let me go onto my flash drive and save it. This brings up the export options. Right? Generally, if we stick with 2004 polylines, we have pretty good results. Right? So I'll go ahead and say OK. And this then generates an AutoCAD file that I can work with and manipulate and laser cut, etc. Okay? So the purpose today is really practicing the contour in those three directions. right? If you don't fully make it to the AutoCAD, I'm not overly worried about it. I did at the bottom of this say that I wanted you to model a meditation pavilion somewhere on this piece of property and do a few renderings of it. We're going to skip that, 6 and 7, so you don't have to do it. I do want to see the topography. I would love to see an AutoCAD file coupled with a rendering of the terrain itself, so you see the surface. You'll post those two things by the end of class today, and use any extra time that you have to deal with your chairs, right, and your tables. Remember, those are due next week, so time to finish them up, right? And if you have questions or you need help modeling or texture mapping or something, that's I'm around to help you do that as well. Are there any questions? No? Okay. We will come back and cover the SketchUp part of this. Hopefully the computers will be updated by Monday. I'm going to go have a fit over that, and we'll see if we can't get caught up from 2013.